Looking at test number 13, finish through section 12.2. Our study guide for it. Number 1 says solve 3x minus 5. This is one from way back. Equals 2x minus 8 variables on both sides. Put the smaller variable term to the larger side. So we have 2x on the right. We want to bring that one over to the left. It's positive or plus 2x subtracted to undo that. If you do subtract 2x on the right, do it on the left, and that'll leave you with 1x. These will cancel. Negative 8. You got your x's on the left, so bring everything else to the right. Get rid of minus 5 by adding it. Do the same thing on the right to balance it. X equals, these will cancel, negative 3. Number 2 says the perimeter of the rectangle is 24 centimeters. Solve for x. Well, your perimeter equals 2 times your length plus 2 times your width. Remember, or it's the distance all the way around. Okay, we had to make a small change. It's 42 centimeters instead of 24. But it's still perimeters 2 length times plus 2 width, or 2 times the length plus 2 times the width. If we know our perimeter is 42 centimeters, and we doesn't matter which one you call length and which one you call width, let's just keep it consistent. We'll say this one's length and this one over here is width. 2 times your length is 2 times 12, plus 2 times your width is 2 times 3x. So notice we went from having 3 variables, P, L, and W, and now we only have 1 variable, x. So we'll go ahead and simplify it. 2 times 12 is 24, plus 2 times 3 is 6x, equals 42. Then it becomes just like the problems we've been looking at. Get rid of positive or plus 24 by subtracting it. These will cancel. 6x. Get rid of 6 times x by dividing it. Do it here as well. X equals 3. And that's all you're solving for x. Headed x, for the length, you'd plug it back in. Your length is 12, I should say. Or headed x, for the width, you'd plug in 3 and you get 9 centimeters for your width. 60 miles an hour is how many feet per minute? So we're going 60 miles per 1 hour. There's 5,280 feet in 1 mile. So if we're going from miles per hour to feet per minute, so we're making 2 conversion changes. The first one we'll do miles to feet. Miles to feet. That's 2 distance measurements. So we have miles on the top of our first fraction. That means we want to put 1 mile on the bottom of our second fraction. And then you put the distance of how many feet are in 1 mile at the top. 5,280 feet. That's the first conversion. The second conversion is from hours to minutes. Notice in your first fraction, you have 1 hour on the bottom. So the one that you're multiplying by, you want it to be opposite. You want 1 hour to be on the top. And you know that there are 60 minutes in 1 hour. At this point, you can cross out all of your units that cross each other out. So notice miles is dividing by miles here, so they can be crossed out. And hours is dividing by hours here, they can be crossed out. Notice the only unit you have on top now is feet, and the only unit you have on the bottom is minutes. When you multiply 60 times 5,280, you get the number 316,800. That's 316,800 feet. And if you go straight across at the bottom, 1 times 1 times 60, that's per 60 minutes. But it doesn't say per 60 minutes right here. It just says per 1 minute. So what you need to do is you need to divide 316,800 by 60. And it tells you 5,280 feet per 1 minute. And if you think about how much sense that makes, you're going 60 miles per hour, and there are 60 minutes in an hour. So that means you're going 1 mile per hour. Number 4 says solve 10 over 7 equals 20 over x. Dealing with proportions, cross multiply. 10 times x is 10x, and 7 times 20 is 140. Get rid of 10 times x by dividing by 10. Do the same thing over here. X equals, since these cancel, 14. Graph X says is greater than or equal to 2. So it's only one variable. You're not graphing it on a Cartesian plane. You don't need that since it's only one variable. You're only graphing it on an X number line. Remember, just show 0 and show 2's relation to it. We know it's positive, so it'll be over there on the right-hand side. Greater than or equal to means you're going to have a bubble that is colored in. Colored in bubble. Greater than means everything this way. The alternative you could have used, remember, is a bracket with everything showing this way, not a parentheses. Bracket means count the number. If you left an open bubble, go ahead and color it in. Number 6 says write the inequality of this one. So now it's an open bubble, so it's saying greater than. So X is greater than, and it's at -2. Notice it's not a colored in bubble. That's why it's not greater than or equal to like number 5 was. That one said or equal to there. That's why we have a colored bubble. This one is an open bubble. Number 7 says solve, then graph. Here's a compound one. We hadn't seen one like this in a while. Remember, you act as if one side's covered up at first, and you do the other side. Let me uncover it real quick. In fact, let me move this over just for a second. There we go. You act as if that side's covered up, and then you work it just like you normally would. Please excuse my dear Aunt Sally is what we do when we're simplifying, but when you're undoing something, you work backwards. So you look for addition and subtraction first. You see -4, so undo that by adding 4. You add 4 to the left, add 4 to the right in this case. That'll leave you with 2x is greater than, you don't change that symbol because all we did was add it right there. 6 plus 4 is 10. Then get rid of 2 times x by dividing by 2. If you divide the middle in this case, or the left by 2, you divide the right by 2. So you have x, and we divided, but it was by a positive number. So again, we do not flip the sign, is less than 5. So that's what it would be if it was only one side like that. But since it's a compound side, we need to look at the other side as well. So now if we cover up this side, we do the exact same thing. We add 4 to the right in this case, so add 4 to the left. -6 plus 4 gives you -2. And again, all you did was add it, so the sign stays just like it is. It just comes straight down. Then you divide it by 2, so divide by 2 on this side as well. Now you're dividing, but it's still by a positive number. The fact that you're dividing a negative number by it does not flip the sign. You're dividing by a +2, so it stays as less than or equal to just like it is, and -2 divided by +2 is -1. So now when you look at your entire compound inequality, it looks like this. -1 is less than or equal to x, which is less than 5. Then graph it. Remember, you want to graph it as 2 separate ones, just happen to be on the same number line. We know we need the number 0 just to show relation. We know we need a number that's +5, and we know we need a number that's -1. Remember, that's going to be a little closer to 0. So if we just look at this part of it, again, if we need to cover it up again where we can see, if we just look at that part of it, x is less than 5. So wherever 5 is, remember that's a color, that's an open bubble because it doesn't say or equal to. Less than, remember your smaller numbers or everything going that direction. The other half of it says x is, now you got to look at it, it's backwards the way it's written here. That's backwards. If you read, always read it from the variable. If you need to rewrite it, go ahead and do so. X, notice the open side, the bigger side is to the x side. So it's greater than or equal to -1. All I did was flip it around. So we'll graph that. X is greater than or equal to -1. So -1 is here. Greater than or equal to means color the bubble in, and greater than means everything this direction. So it's going to be between the two numbers, 5 and -1. With an open bubble on a 5 and a colored one on a -1. Number 8 says simplify the square root of 100. Remember, all this symbol means is what times itself gives you 100. 10 does. Not 10 times 10, not the square root of 10, just 10. Notice it comes out of the radical. This one says the square root of 2 over 25. Anytime you have a fraction under a radical like this, always separate it as the square root of 2 over the square root of 25. Now it says what times itself is 2. There is not a perfect square, so we'll leave it like that. But then it says what times itself is 25. 5. This is a simplified radical expression. The reason it is because there's three questions you have to ask yourself. One is, can I multiply a perfect square by something and get the number 2? Remember, your perfect square is 2 times 2, 3 times 3, 4 times 4, and you can keep going with all of those numbers. None of those multiply by something to give you 2. The second question, is there a radical at the bottom of the fraction? Like this? No. We had one, but we got rid of it. The third one, is there a fraction under the radical? That's how it was at the very beginning, like 2 over 25. No. We have a radical, but then we have something at the bottom. So it's not one of those. So no, no, and no. That's why it's simplified as the square root of 2 over 5. Next one says the square root of 24 over 2. Again, simplified, separated. The square root of 24 over 2 over the square root of 2. Now, there's a perfect square that goes into the number 24. So if we look at that one, we know the number 8 can multiply by 3 to give you 24. I'm sorry, 8 is not. That's a mistake I made. The square root of 4 times the square root of 6. 6 is a perfect, 4 is a perfect square. Now I'm talking below myself. The square root of 4 means what times itself is 4? That's 2 times the square root of 6. So we have 2 times the square root of 6 over the square root of 2. Cannot leave that radical at the bottom of your fraction like that. Can't leave that. So get rid of the square root of 2 by rationalizing it, multiplying it by whatever's on the bottom over itself. When you go straight across, that leaves you with 2 times the square root of 12, just multiplying straight across, over the square root of 2 times the square root of 2 is going to be the square root of 4, which is going to simplify ultimately to 2. Let me roll this down a little bit. So we have 2 times the square root of 12 over 2. 2 divided by 2 will cancel out. We're left with the square root of 12. And again, we simplified the square root of 12 a second ago by accident. The square root of 12 can be broken down into the square root of 4 times 3. So 2 times the square root of 3. And that is your simplified answer. Now, a lot of steps to get to that one. A shorter method would have been to just divide it right away, which I'm sure some of you guys did. Divide 24 by 2 right away, and you'd have got to the square root of 24 divided by 2 would give you the square root of 12 right away, and you'd have jumped all the way down to this step. Would have been a whole lot shorter. But just showing you there's more than one method to get there. Number 11, we have to rationalize this one because there's a square root at the bottom. That just means whatever's at the bottom, multiply it by it over itself. 3 times the square root of 5, you write it just like that. 3 times the square root of 5. It doesn't give you the square root of 15 because one's a radical and one's not. The square root of 5 times the square root of 5, you need to write this step as 25, square root of 25. That simplifies just to whatever that number is underneath the radical. So over 5. That's simplified. We passed the 3 questions. No perfect squares, no fractions under the radical, no radicals at the bottom. Number 12, we have to do this one as well. We'll simplify the top real quick, though, to make it easy. 9 times the square root of 9 means 9 times 3 over the square root of 45, which is 27 over the square root of 45. We could simplify the square root of 45 as well, just like we did the square root of 9. 45 separates into the square root of 9 times the square root of 5. Square root of 9 is 3 times the square root of 5. So now you have 27 over all of this square root of 45 became 3 times the square root of 45. So 27 over 3 times the square root of 5. 27 divided by 3 can be simplified. 3 goes into 27 9 times, and 3 goes into itself 1 time. So you have 9 over the square root of 5, much smaller numbers to deal with at this point. Get rid of the square root of 5 at the bottom by rationalizing it. The square root of 5 over the square root of 5 leaves you with 9 times the square root of 5 over 5. That's simplified. Now we're simplifying. Remember, if this had said 4x plus 6x, you would just add 4 plus 6 and you'd get 10x. It acts the exact same way with radicals. You have 4 times the square root of 5 plus 6 times the square root of 5. So leave the square root of 5 and add 4 plus 6 and you get 10 times the square root of 5. Number 14, we don't have the same radical now, 5 and 5. So what we need to do is we need to break this one down using perfect squares. Remember, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. We can multiply one of those numbers by something and get the number 80. It might not be apparent which one to use right away, but you can clearly see that the number 4 goes into both of them. Watch, it's just going to turn out to 2 steps for us. The square root of 4 times the square root of 20. That means 2 times the square root of 20. But the square root of 20 can be broken down as well, again, using 4. The square root of 4 times the square root of 5. So 2 times the square root of 4 times the square root of 5 means 2 times 2 times the square root of 5. A whole lot of breaking down to get 4 times the square root of 5. That's what the square root of 80 is. So if we bring everything, this is the square root of 80. So if we bring all of that down and move all of that mess out the way, what we're left with now is 6 times the square root of 5 minus 6 times 4 times the square root of 5, because that's the square root of 80. You can multiply negative 6 times 4 and get negative 24 times the square root of 5. Bring this other side down, 6 times the square root of 5. Now you have the same radical again, just like the last problem. So leave the square root of 5 and take 6 and subtract 24 from it. 6 minus 24 is negative 18 times the square root of 5. 15 would have our first FOIL problem. It doesn't say FOIL until a couple of problems later, but you still use that method. You'll notice this one is a conjugate, though, so you can actually skip 2 of the steps, but we'll do them real quick just to show them. Your first 2 terms you want to multiply. 9 times 9 gives you 81. That's F. The second one is your outside terms. So 9 times the negative square root of 2. So that's negative 9 square root of 2. The next one are your inner 2 terms. That's these 2. Square root of 2 times positive 9. So plus 9 square root of 2. And then finally, the last ones are your L's, your last 2 terms. Square root of 2 times negative square root of 2 is a negative square root of 4. Anytime you're doing conjugates again, you can leave the outer and the inner ones out, because watch, negative square root of 2 and positive square root of 2 will cancel each other out. So you have 81 brought down, and then minus the square root of 4 means minus 2. So 81 minus 2 is the number 79.